Hello, everyone. Thank you for joining us for today's Kuringo Tech Tuesday webinar. This session's topic is Developing Cloud-Native Applications. I'm Sarah Cook, Director of Marketing at Kuringo. Today, our subject matter expert is Ryan Meek. Ryan will be available to answer your questions throughout the webinar and also at the end of today's presentation. Make sure you stay with us until the end, as Ryan always has some good parting words of advice. In addition, we have some resources available for you via the attachments and links window on your view screen. If you have any questions after the webinar, you can always reach out to us via email at info@kuringo.com. So a little bit about me. I've worked for industry giants like EDS, Tandem Computers, I know that one's really going to date me, Cisco, and Dell. But I have to admit that after 5 years at Kuringo, it really feels like home. So as a marketer who likes to pull in the technical staff for projects, I've never found a place with more willing victims. With that, Ryan, why don't you tell our guest a little bit about yourself?
Well, thanks, Sarah, and thanks everyone for joining us. I'm Ryan Meek. I'm the Principal Solutions Architect at Kuringo, and I joined the company in 2006, right before version 1.0 went production. I joined as a developer, and I've done development, training, technical account management, and technical sales in the field. So I've had a good view of not only Kuringo and storage, but of the development of application technologies through those years.
Great. Well, since normally as the hostess or host, however you prefer to say that, I would give a Kuringo overview at this point in time. But given that Ryan's been with Kuringo 3 times as long as I have, I decided I should really give him that honor. So Ryan, take it away.
Thanks, Sarah. Yeah, so like I said, version 1 came out in 2006. We were actually founded in 2005. I think if we're going to go into a bit of the history lesson, the first time I heard about the company was in 2005 at a place called the Dog and Duck Pub on Guadalupe in Austin, Texas. So that might put it in a little bit of context for you, a classic. We are no longer a startup. We're on version 11.3, market hardened, deployed all over the world. I think every continent except Antarctica, last time I checked. And we focused over the years really in federal government spaces, primarily because of our early focus on compliance and scale, also in high performance computing, especially because of our scale and sort of scale out qualities in the infrastructure. And more recently in media and entertainment, especially because of the growth of video and the high performance aspects of being able to stream content directly off storage and kind of unify the sort of storage and web service tiers. So that's sort of been the places of the market that we've focused, a little bit about why we got there. You know, in the federal space, it's been, you know, the U.S. governments in Europe and South America. High performance is generally things like national labs and university, and media and entertainment right up to top streaming brands launching local sort of over-the-top services and channels.
Well, I would say maybe never at any time in history have we had so many people binge streaming so many shows.
No, that's true. It seems like everyone decided to fire their cable company in the last couple of years, and all the channels decided to put all their content online, which we were really thrilled with. You know, we've been stressing the put it all online aspect for years, but you know, more recently, and I guess unfortunately due to COVID, the practicalities of having people in the office actually having to touch things, you know, finally became a little bit too much, I think, and people accelerated their product roadmaps and included, you know, finally putting everything online that had been accumulating on the shelves. which really kind of gets straight into, well, what do you do with the content once it's online? That's really the developing the applications and connecting it with the end user aspect. And there's been various schools of application design, and it wasn't even really differentiated from software development in the beginning. You would just hear maybe object-oriented programming, and then maybe some model view controller design patterns. Then later in the 90s, sort of service-oriented architectures, and now sort of cloud native is all the trend, and that incorporates a lot of the same elements as service-oriented architectures, but it's also different. So we'll go through what it is, the benefits, mistakes in data design, best practices, and then specifically developing those apps with Kuringo Swarm, and some QA and wrap-up. Yes, Sarah.
So what is cloud native, Ryan?
Right, perfect transition. So this is talking about apps that are specifically designed to run in a cloud architecture. And as a practical matter, I think that generally means either Amazon AWS, Microsoft Azure, Google Cloud Apps, Google Cloud Platform, or private clouds, or sort of a hybrid. The Cloud Native Computing Foundation, so I think that's really the most stable place to put the moniker, is a Linux Foundation project founded in 2015. It was actually founded coincident with Google releasing Kubernetes 1.0 as the foundation for the container services that are not exactly synonymous with the movement, but certainly, they're a foundation technology for the movement. So why do people go into a cloud native approach? What are the benefits they're looking for? Really specifically being able to scale along with the numbers of requests or the numbers of users. You see this a lot in web architectures, or you see it start in web architectures. Canonical examples would include something like Netflix, that famously developed their platforms completely inside of AWS, and could scale things like caching proxies or video delivery systems as needed. Like the more users fired up, the more virtual machines or containers, containers they could launch that would actually handle that infrastructure. So that's an elastic infrastructure. And these would be leveraging immutable infrastructure, specifically container-based. And what that really is that's saying, well, what if we package all the dependencies that we need for the application with the application so that we can spin them up with as little variation as possible, technically and ideally no variation on a per instance basis. The only variation would be sort of delivered at run and launch time through configuration. And then these could run on, private, public, or hybrid clouds. But I think early on that was really focused on public clouds. And then the extension to private and hybrid, I think, was probably a little bit later. And so big benefits: elasticity, massively parallel, portability of code across operating systems. So CoreOS is going to be the most probably common one in there, but really anything that can run containers, including like, Docker desktop on my Mac can reliably run a storage infrastructure running Kuringo services. And repeatable processes, the more infrastructure that is sort of declared and comes directly out of the source control system, the better you are on the quality scales, and the less you have admins changing things in the field and creating large mysteries in behavior.
Large mysteries in behavior?
Yeah, so that kind of gets back to the, well, all the behavior should be somewhat declarative, like this container or microservice accomplishes this task, and it is really sort of atomized to one group so that changes can be made to it without having a meeting between a lot of other groups. And it does something simple. It's something that could be understood, and it's actually represented in code and documentation, and changes to that are also something you can find in a source control system. Before this kind of movement, there would be a lot of behavior in the system that was mysterious and generally attributable to some well-meaning and very smart sysadmin administrating services and tuning applications in the background.
Okay. Or mysteriously changing a piece of code?
Changing a piece of code is even worse, but even, changing really anything. I mean, changing code, changing statistics, changing configuration settings on the fly without any record of those in configuration management systems or source code management systems. Happens all the time, but the farther you get towards a system of record, the better off you are, really.
And on the topic of mistakes, what are the top 3
That's
mistakes
right.
people can make in data design for cloud native?
Right. So data systems are sometimes kind of at odds with the ideas of the cloud native systems, just because cloud native systems really want to be, they want to be very immutable, and storage is mutable by nature, right? They want to be, immutable, have a very consistent configuration, but you have to put the data somewhere, and that's always going to be changing. And so when you put those together, it could get very complex. It could actually be the most complex part of the system, setting up a good cloud native, distributed storage system. So one big mistake, forgetting locality really matters at scale. So one thing that you see in cloud native infrastructures is people are spinning up services, but the right configuration values need to get to the right containers. Otherwise, requests may be made, across regions or across pods. Across pods would be more common, but across regions could happen as well. This is going to be HTTP predominantly, and latency actually will kill throughput in those environments. So, big lurking performance problem that can be difficult to troubleshoot, especially if it's just happening sporadically. And the workflows themselves can be fragile in those cases. So we've worked with people that are doing cloud native, and sometimes those workflows can actually break down if data appear in one region but not in another region simultaneously. And so, really understanding if data will be available everywhere at once, or whether, say, steps in a workflow need to pause or poll for existence of things that may be showing up. So more specifically, if one satellite picture shows up near the source, maybe it also shows up in a data center in New York, and then at some point later it shows up in Amsterdam. Well, you don't want all the services in Amsterdam to actually crash if they try to operate on that data and it's not there, or operate on that satellite picture and it's not there. That will just give the whole system the idea that something's wrong, when really it's just the physics of data getting from one region to another. And oh, by the way, systems that are mature, like Kuringo Swarm, they do have features that can guarantee a synchronous write across multiple regions to accommodate those kinds of workflows. But ideally, the workflows wouldn't be that fragile, I would say.
Okay.
And then another big mistake is just forgetting about ingress and egress charges for data on public clouds. I mean, we all know they want to make it cost effective for everyone to put all their data into the public cloud. But then, Amazon S3 or Glacier gets expensive when you want to take the data back out. There are bandwidth charges. And so forgetting about what data is where, and then forgetting about the actual expense of where it needs to go is something that can be an eye-opening experience for the person that finally gets the bill. So that's really a little bit separate from cloud native in general, but that's really sort of the intersection of data and cloud native.
Hey, you mentioned HTTP accessibility, and now you just mentioned Amazon S3. So how important is the S3 part to cloud native?
Well, I think it's pretty important. I mean, S3 is an excellent object store. It's available worldwide. They have excellent, they have excellent facilities for things like CloudFront, for things like load balancing, for things like web addressing, for DNS. But, you pay for it. And so I would say it's a foundational technology. It's really important. Object storage in general, it's great to have an identified object that is available online regardless of its actual location. And so I would say it's definitely a foundational technology. It's a great product. It just, it costs money, and it can cost a lot of money if it's used incorrectly.
Well, we don't like to spend more money than we have to.
No,
that's a pretty universal concept.
People notice that really quickly when they get the bill.
Mm-hmm.
So best practices, people generally talk about a microservices architectural approach. That's really specifically getting atomic with the services that are available in the containers, all the way down to microservices level inside a container, inside pods. And a big idea here is you shouldn't have to have a meeting across groups to decide the behavior of what to do inside one of these. And they should be packaged with containers along with their dependencies, so that you don't end up in these cross dependency trees that are just so complex that different parts of the application interfere with the upgrade paths of other parts. I think we used to refer to this as RPM hell way back in the day, but I think a lot of this is a response to that kind of problem. And it's just RPM, like any other application. The Red Hat Package Manager, sorting through the dependence tree. Yes, sorting through the dependence tree of individual applications, and then having those dependency trees conflict with each other was not fun, and not cost effective to sit there and work through. And if you could package the applications with all their dependencies, then it's just not as brittle. It's a way to make things more stable. And developing cloud native apps is a lot like developing other apps. The agile methodologies are just as useful. Quick iteration, quick feedback from testing and users, these things all still apply. So what about developing cloud native apps specifically for Kuringo Swarm? So, one of the distinguishing characteristics for Kuringo Swarm in most cases, vast majority of cases, is it's on-premise and or hybrid cloud specific. So, and on-premise really includes, the idea of in your data center. And so, what are the benefits there? A massively parallel application is a great thing. So designing elastically for scale out, not up, is a key thing. What's the difference there? It's sort of the idea of, well, it would be better to scale out multiple instances of, a video delivery system or of a, video indexing system than to put more and more resources into running the same containers or pods. And architectural ideas like transaction IDs and tracing transactions through multiple systems is all still very useful. As far as the scale out, scale up idea goes, I think tuning for ideal thread pools is a really good idea to keep in mind here. So Kuringo Swarm is, storage with an HTTP API. You can really think of it as not a microservice at all, but a full-fledged service, almost in the service-oriented architecture sense. But it would not be ideal for a container to fire up and keep, say, one thread. It would probably be most efficient for a container to fire up and keep as many threads as there are nodes in the Kuringo Swarm, so that there could be at least one active thread per node, and redirects would not incur a connection fire up, fire down cost. And so there is some tension there between, how many instances of an application to run, how many connections to keep open, and, how many pools to keep open, of course, with keep alive sockets. But I think an ideal size is going to be something like the number of nodes in a cluster. And then there's really no worry there that you'll run out of things like connection handles or socket resources on a system. And then I think one thing to keep in mind there too is just, what your limiting factors are. If it's a small file use case, your limiting factor is going to be HTTP. So you will have a somewhat, latency dominated profile, and CPU will be more and more important. And if you have large files, it's really network throughput that will probably be a limiting factor. CPU is important there as well. I guess in the small file case, there's probably more latency. And so, if it's many small files, maybe more cores would be more important than CPU clock speed, for instance. But for large files, you really want to think about, what's your network throughput? Should there be many containers running caching proxies, for instance? So it's actually, serving much content directly out of RAM, or how many connections do you want actually going back to the storage pool? And in general, we've also seen quite a bit of value from things like promotion chains. So let's say you're developing a set of cloud-native apps. It's very good to have a development cluster to run those tests against that do not affect the quality of service of the production cluster. And QA, if you're lucky enough. Then the apps can actually be promoted. They can be pointed to a development cluster. Everything can pass. They can be pointed to a QA cluster. Everything can pass. They can be promoted to production. This can be repeatable. It can even be automated. And so we see the more mature software houses having methods like that, just to ensure sort of continuity and a high quality level. I think that's actually one of the most helpful. That's one of the most helpful characteristics of a mature process is actually having different clusters for development and QA, that have actually run through a full suite of tests before getting to production. Then you don't have to make those nervous jokes like, we don't always test our code, but when we do it in production. You know, shops know they're doing the shops know they're doing the wrong thing when they're making those jokes, and just pointing that out can be the first step towards a best practice development.
Well, yes, it does seem like a good idea to test your code before you put it into production.
Or yeah, exactly. Or you know, test it, but not on the production cluster, for instance.
Right. Right. Well, cool. Well, this was definitely a new topic for me. A little bit deeper dive into the weeds than usual.
Well, it's interesting. They are weeds, and there are a lot of recent weeds too. There have been quite a few people putting a lot of investment into these systems, and I would say that they've been very successful in delivering a more stable application framework, especially for web technologies, and especially for what you would think of as like bits in flight, or you know, content delivery online. I think things like storage systems or relational databases that are more like where the actual data goes to live will be slower to adopt these generally. But you know, we see it in the field when we work with customers developing the applications. We're actually leveraging it to provide, you know, things like mobile clusters and you know, clusters on the edge, closer to the edge, especially for IoT and things like that. So it's super interesting, and it's great to watch. It's a good thing to keep our eye on and use internally and leverage as well.
Great. So I guess we are ready to go into our standard wrap up. So thank you, Ryan, so much, and thank you all for joining us today. You can always keep up with us through Twitter, LinkedIn, and Facebook. And if you have any additional questions or you'd like to schedule a custom demo, please email us at info@kuringo.com. I'd also like to invite you to join us in November for our next Tech Tuesday webinar, where Senior Consultant John Bell will be back in the host seat with Eric Day, Director of Product, as the guest. The topic next month will be intelligent data management for access, archive, and content. So something that's very timely right now, as people are looking to store more and more data. So, Brian, any sage words of advice for somebody who's heading down the cloud native path?
No, I would just say it's a really interesting path. Feel free to reach out to us at any point if you have specific questions about integrating it in a Kuringo Swarm context. We'd love to share our experiences with you, and feel free to reach out to me directly in any of the usual ways.
Great. Thank you.
Thanks, Sarah.